Ryan Krikorian. He says he has an answer. So take it away, kiddo. What do you got?
X is equal to 9, and then y is equal to 9 times the square root of 3.
Ooh. Question, those of you guys with a decimal, does it equal 9 root 3?
Yes.
Yeah.
So what form would I ask you to keep it in?
Wait, yeah, isn't
it y equals 9 and x equals 9?
No.
Yeah.
No,
Think
about it. The y is longer than the y is longer.
Yeah.
I don't know.
And this one, the adjacent side to the 60 is.
Y is
You're
equal
probably
to
right.
9 square root of 3 is 15.
Why is someone talking about adjacents?
Because adjacent is supposed to be.
I thought, wait, I thought
I
in
was
geometry
wrong.
this was just like a memorize or else, right? Memorize or else, because you have a, how does it work in geometry?
I don't know.
It's a 1, 2, 3, but where's the 1 and where's the 2 and where's the 3? The 1 is across from,
The theta of the given angle.
The right angle.
Which
the
one's-
one's across from the right.
which one's bigger? The 1, the 2, or the 3?
The
Yeah,
1.
Well, I should be asking which one's smallest, probably. Which one's smallest? The 1. And so which one is the smallest angle? For geometry, the smaller angle has the smaller corresponding side, the larger angle has a larger corresponding side. Where's the 1 going to go? Across from the 30. So I have 1a. Now, here's the weird thing. Is the 3 actually a 3 for the 1, 2, 3 triangle?
No, it's just square.
It's a square root 3, right? So actually, square root of 3, isn't square root of 3 in between square root of 1 and square root of 4? Isn't it between?
Yeah.
Why am I saying that? Well, that's the 1, that's the 2, so where's the root 3? So you go 1 with the shortest angle, 2 with the largest angle, aka the hypotenuse, the largest side. So it's a 1, 2, root 3 triangle. One way of remembering it. And so then you could think about geometry if you wanted. I heard some of you guys saying something like 18 is double of what, right? So you could say 18 is double of, and then that's how you get 9. And then this guy would be 9 root 3 as a result. That is one way. That's the geometry way. If you were thinking about 18 is double of what, and then working your way backwards, you were using the geometry way. However, those of you guys that were saying things like opposites and adjacents, what were you thinking about? SOHCAHTOA. You could have been thinking of something like opposite. Well, let's do adjacent because that's first, right? That X comes first in the alphabet. So we could say that cosine of 60 is equal to adjacent over hypotenuse. If you know your trig really, really well, you could just be thinking of what's the cosine at 60. But the question is, do you know your trig really, really well? Where's 60? He's less than 90. He's in the first quadrant, but where is he? What fraction of pi is 60? So I've taken my calzone and I've cut them into thirds. Anybody eaten a calzone yet, just in honor of trigonometry? Yeah, buddy. Who has never, ever had a calzone before?
Let's go.
Every year. It's so sad.
I'm glad to say that.
You should bring some.
I asked for it.
You were denied.
I asked my parents.
Yeah,
They
with the
said
pizza.
no.
So I should send a parent email and be like, please help your students celebrate
Please, it'll help me
trigonometry
understand
can't
the
take it
math more.
seriously.
by getting them a calzone.
Wait, technically everyone who's had pizza had a calzone.
No, that's
No,
not
no,
how it
no,
works.
no,
That's the same.
No.
That's not how.
It's like saying someone that's had a hot pocket has had a calzone. That does not count. That does not
Hot
count.
pocket's kind of busted.
Everyone who has had a hot dog
Which
has had a
one?
corn dog. Not true.
Now, are there similar tastes in a calzone that are in a pizza? Yes, but a very different experience. I think, Johnny, right? Very different experience?
Yes.
Very different experience. Okay, so coming back to the calzone that everyone should try. That is your homework for Thanksgiving break. Maybe I'll make it worth bonus if you send me a picture with a calzone. Oh, it's an assignment. They got it now. All right.
That's how I got it.
I think we did this last year.
Eating food?
No,
That was for Pi Day.
That was
Oh,
so
yeah.
I sent a picture of myself with the clock at 3:14.
Yeah, me too.
Pizza.
Okay, coming back. Why did I ask what portion of pi that would be? Well, because shouldn't you guys with 1/3 get right here and not right here and not right here, right? There's a 1/6, there's a 1/4, there's a 1/3. 1/3 is obviously, okay. Why am I showing this? I'm showing this because, remember, we were starting to connect to geometry last time. That's what this section is for, connecting to geometry. Yes, there's an ordered pair. But that ordered pair has a, maybe close the door, Lucas. I can't handle the little ones today. Okay. The ordered pair has a meaning. For those of you that memorize the ordered pair, that's cool and all. But it has a meaning. And the meaning is, you go over a little and you go up a lot. You go over the smaller and you go up the bigger. Not the smallest, which is 0, not the biggest, which is 1, but the smaller and the bigger. You guys remember what those ratios are? What's the smaller one? 1/2. What's the bigger one? Square root of 3 over 2. So you could just be like, oh yeah, it's the 1/2. Oh, cosine is equal to 1/2, so therefore I could say 1/2 is equal to x over 18. A quick little cross multiplication, which is just algebra. Multiply up the 2, multiply up the 18. You end up with the exact same thing that your true, except. True, except. We'll take Jackson's question, and then we'll see what the except is. Jackson, go ahead.
Okay, just like,
Go for it. You're good.
well, we have like a unit circle on the test. As if we know.
Well,
I don't have a photographic memory.
here's a question. Do you think in this class, just troubleshoot with me. Do you think in this class that I strive for rote memorization very often?
No.
How do you, oh, maybe, okay. But what makes you answer that way? Let's talk and see how well you know me. As a teacher.
It's like learn, like not like just memorize.
We haven't really had any.
What do you mean I want you to learn and not just
There
memorize?
are things that are very.
Like, to apply it.
I'm trying to get you to apply it. What are you saying, Johnny?
There are things that are important that we do need to memorize, but there are some things that we could. I don't know.
He's thinking maybe like some things don't need to be memorized, other things do. I'm not the one teaching you your times tables, although those would definitely help you to have
Like
memorized.
formulas, I feel like should be like memorized, like distance and stuff like that.
Yeah, there were some of those.
Like a unit circle.
Let's go, can we go back to section 1 for a second? There's actually a BC kid that reminded me of something. Not reminded me, but she said like a special thank you for something in how I teach, and she actually quoted the very first section of pre-calculus. Can you go turn back to the very first section of pre-calculus? She was like, you know what, the very first day I had you as a teacher, I knew that I was going to appreciate you. Now, pause, that's not everybody's brain, so don't worry. I know some it doesn't connect well. But what did I do in the very first section this year that might have been a little different than others have done? Did anybody catch it?
Oh.
They were formulas that theoretically you had memorized before. But what did I do that was different, Ryan?
Didn't we just like write down a bunch of like formulas that we would like need to know in general on like one place, so, like if we had to look back?
Okay, maybe I was giving you like a reference guide and I was trying to show you like, hey, we're making our notes into something that you can continually refer to. Made a table of contents to make it easily organized. That actually wasn't what she was thanking me for. You did graph. I didn't. Keep thinking. Give me one of those formulas. Was there any of those formulas?
Yes.
What's one of the worst? Oh, we can do midpoint or distance.
Midpoint's pretty easy. No.
Why is midpoint pretty
Quadratic
easy?
formula.
It's just like slow.
And that's in like chapter 2 if you wrote it down. With the quadratic. Either the midpoint formula or the distance formula. You guys did say I graphed, but I didn't graph with that one. I actually graphed with this one. Why did I graph with the distance formula? You remember what I did? Either one. I did something that the students thanked me for. I did it in both these formulas, and she remembered it on senior retreat this year. It was random, but she did. How did I teach these formulas?
It was.
How did I teach them? Ryan, don't worry, I haven't really written anything. I've just said, like, hey, midpoint, there's a formula, distance, there's a formula. How did I teach them? Feel free to chime in, Ryan, if you remember it. Does anybody remember how I taught the midpoint formula? You can tell me what it is. What is the midpoint formula?
x1 plus x2 divided by 2, and then y1 plus y2 over 2.
Cool.
equals
So
X, Y.
Joey, I think, likes to memorize and tends to hold on to things, or
Well,
you
it's
just
right
reading
in
it off
front
the
of me.
page. What was the idea behind this one? Does anybody
Oh,
remember?
Find the average.
Yeah, you gave
Find
us
the
idea.
average.
Like, yeah, find
That
out.
one I remember.
How many of you guys remember how to average things?
Oh,
Divide by the number of items.
Did I teach the midpoint formula by saying, hey, you better have this memorized. If you don't have it memorized, memorize it?
You taught it to us by it's the average of the X points and the Y.
I said there's another way of thinking about it, right? Now, question. Could some of you just be like, I memorized by memorizing and that's how I have things memorized? Yes. But do you have to? For most things in my class. You need to learn them. But I try to show you multiple ways so that you can choose one that's best for you. Right? Does anybody with that remember what I did with the distance formula?
Cut it in half.
Oh, did you do rise over run?
Yes.
I mean, that's
I remember
that's
that.
all I
Oh, I wrote that down, but
I mean, I just did.
But the rise, wasn't the rise just the change in y's? Because it's how high minus how low?
Oh, isn't it?
Isn't the run how far between the x's? What theorem, what formula allows us to find the distance without just rote memorization of that big nasty square root thing?
Square.
Isn't it technically just a squared plus b squared square rooted, where a is equal to the distance in x's, and b is equal to the distance in y's, and it's all square rooted because I need c squared, but just by itself. Now,
Dang, wait.
once again,
Wait a minute.
Oh my
the
god.
first day of class,
That
maybe it
click
didn't
on the
really
first day
click,
of class.
but that's how I presented these formulas. Once again, maybe it didn't really click.
So how are you gonna do it with the unit circle?
A squared
Okay.
plus B squared.
So, back to Jackson's question. Why did I go into this long aside? Was it cool that this girl remembered it? Yes. Does my brain and her brain, do we think similarly?
Yeah, the photograph.
Possible.
Are you guys telepathic
Yes.
communicating right
She has the photographic memory. It's not fair.
now? No.
Yeah, she probably has photographic memory.
No. She does have a good memory. But I wouldn't say photographic. She works really, really hard. And it's also very, very artistic, so you guys might be able to figure out which one I'm talking about. But, coming back. What does that have to do with Jackson's question of, will the test have a blank unit circle that you need to fill in? Question.
Hard to know.
What does the unit circle give you?
Radians.
Oh, it gives you a way of remembering
Use
radians,
the
yes.
X and Y axis.
It tells you where you are.
But what do you get? I mean, an X and Y axis you've had since like algebra 1.
It tells you like the measurement at a certain point, or like the degrees.
It helps you remember degrees, helps you remember radians. But what is it actually giving you in those ordered pairs?
Coterminals.
No, that's something you would have to know,
it's
right?
giving you the angle. Because like if you just draw it down.
But if it was just giving you angles, I would just do some sort of like throw angles at you with protractors or throw angles at you. Like the unit circle does organize angles, but if you search the unit circle, you shouldn't just have angles. What else are there?
It gives you order pairs and degrees.
What do the ordered pairs mean? It gives you ordered pairs at angles. The ordered pairs for angles.
When the radius is 1.
Sines and cosines. It gives you sines and cosines. Sines and cosines of special angles. Sines and cosines of select angles. Sines and cosines that we can know perfectly, not in decimals, with root 3s, root 2s, 1/2, etc. So, what was I about to do here when I was drawing a triangle? Jackson, I'm getting to your question, but hold on. This is a snapshot of the unit circle, true?
Yes.
But why am I here? I was here because I was going to remind you of a couple things, like, remember, the unit circle has a hypotenuse of what? 1. Now, I could use geometry to help me get a cosine. If you guys have this thing like solid, cool. Draw your triangle and be like, oh, it's a 60, so adjacent 1 over hypotenuse 2, and you're going to get your 1/2. But if you're in your unit circle, and if you know your basic 5 values of 0, 1/2, root 2 over 2, root 3 over 2, 1. If you know those basic values, you should be able to think of, hey, is it on an axis? Then is it the smallest or the biggest? Here, it'd be the smallest y, which is 0, and the biggest x, which is 1. At pi over 6, I'm going to scale back the x to be root 3 over 2, and I'm going to scale up the y to be 1/2. If I move back to 45 or pi over 4, I'm now at the middle. Middle will be root 2 over 2 root 2 over 2. If I come back even more, my x is now the smaller one, which is 1/2. My y is the bigger one, root 3 over 2. And then when I'm right here, my x is the smallest, my y is the biggest, 0, 1. And I can take that around the entire circle, and I can use the first quadrant for the second, for the third, for the fourth, but what am I doing? What are you doing? What are people doing in the unit circle? Trying to give you a way to quickly come up with sines and cosines of special angles. 30s, 45s, 60s, and in radians, pi over 6s, pi over 4s, pi over 3s, and pi over 2s. So, all that to say, if this is a 1, adjacent over hypotenuse, guys, who's adjacent over hypotenuse again? Cosine. So adjacent over hypotenuse, here's my cosine. What's opposite over hypotenuse? It's over 1, so it doesn't matter. What's opposite? Sine. So why does the cosine go with x? Because of geometry. Why does the sine go with y? Because of geometry and how a unit circle is laid up. But are there other ways to memorize these key or to quickly recollect these key trig ratios apart from the unit circle? Yes, you don't need the circle. You can have a triangle with the right orientation. You don't need the circle. You can have what I'm going to show you called the cheater chart. So Jackson, I need you to be able to quickly recall the special trig values, but I don't need you to fill in a circle. But maybe you need you to fill in a circle. It depends on your brain and how it memorizes. But don't worry, we're not done covering the unit circle. I actually, 4.4, which is where we're going today. Can anybody close to the front read the title at the very tip of the... Oh, it's big. Never mind. Everybody, what's it called? This is us just tackling, like, hey, how are we at coming up with trig functions and quickly and efficiently? So we're just going to keep on working on it. So, is there going to be a blank unit circle on my test? No. Do some teachers do it? Yes. Is it probably a good thing to do in Algebra 2? Probably, because my way of teaching is a bit advanced for Algebra 2 in the sense that I didn't show you everything all the time. I scaled it back, trying to help you, like, get really good at one way, and then in pre-cal, let's expand it and let's go deeper, so that you hopefully have a deeper understanding and don't have to just memorize as much.
What was the title of 4.4?
Good question. It's coming. Trig functions of any angle.
Do you think that we'll need a unit circle in personal finance?
No. Personal finance is more like
Money.
Excel.
financial principles, basics of like budgeting and things like that, and how like loans work, etc. So it's practical, but it doesn't get deep into like economics where the calculus is. Does that make sense? Like an econ sort of thing is where it goes deep into like let's map things, let's model things, let's predict things, let's find the trends. Like that's where the math gets interesting. But like personal finance is just me at home, my books, my life decisions. What's wise.
Like how to be financially sound.
Yeah. Yeah, but not like let's go play the stock market and make predictions, but let's know the basics of money and how it's spent and how it should be saved. Yeah. Good question. But in stats and econ, oh, the math gets interesting. Okay. But unit circle does show up on things like math placement exams for colleges, depending on what our return to normal will look like. I can't really like predict the future. Unit circle does show up on things like SATs to some degree, and unit circle will show up in any sort of college physics, math. Sometimes, I don't know about chem so much. Maybe a higher chem. Maybe higher chem. Stats, possibly. But mostly like the cals, the pre-cals, which is leading you towards like an economics or a statistics or a physics or medical, just for like some of the GEs, not in the long run. And then engineering for sure, architecture for sure, stuff like that. Okay, we have our warm-up. Our warm-up is done. We have our X and we have our, I didn't circle it, but we have our Y, right? Okay. In section 4.3, have you guys noticed in WebAssign? In WebAssign in section 4.3, it's a blended homework again, right? 4.3, 4.4? Okay. Oh.
30 problems. Oh.
I made this slide and then I got distracted by Jackson's question. Now, you asked me, why would I ever use the unit circle when we have the 1, 2, root 3 triangle thing, right? What if I was to do something else, though? And I was to throw in something like, not bad. Okay, usually it's bad because I'm doing it from an angle. What if I was to do something like 47 degrees?
43.
Now, question, is it in the unit circle? No. Am I going to have an exact answer with a radical in it? No. But could I use special geometric triangles to solve for it? Either.
I guess.
No.
Oh.
Well, I could approximate with a 45, but I couldn't do exactly. And a decimal approximation is going to be far better than a unit circle 45 degree, like wrong angle approximation. So if I was to solve this one for x and y, I don't have a choice. I can't go using a special geometry formula. Instead, I have to use the idea that cosine of 47, which I'm going to use my calculator for maybe, equals x over 7. To be honest, I would say the best way of writing this is this, and I would just stop there. However, maybe WebAssign wants you to do a decimal. And what does it say when it wants you to do a decimal? What do the directions normally say? Yeah, it tells you where to round it, or it says estimate or approximate, right? Something like that with a decimal hint about the answer. But what would you need to, depending on what you've been using your calculator for, what would you need to be careful about as far as the mode on your calculator?
Degree mode.
You would need it to be in degree mode, but in another problem, you might need it back in radian mode. And those would give you two drastically different answers because remember, real fast, in green, because this is review, nothing to do with this problem, 1 degree is like, right? 1 degree is that, and 90 of them makes that. What's 1 radian?
Oh.
40.
1 radian is, take it,
One like
twist it, boop, and get to 50, regular pre-cal got it, Ariana got it, 57.3, no, 52.3, 54.3, 1 radian. How would I know what 1 radian is exactly? Well, I could go ahead and do a conversion, right? I could multiply by, would it be 180 over pi or pi over 180? Careful, do I want to divide by degrees?
no, it's 1 equal.
Oh, no,
Ah,
no, get it
careful.
to the degree mode.
Someone divide, what's 180 divided by pi? It's 50-something.4. 51 radian is 50-something.4.
57.
Ah,
57.2957795.
57.3.
Ah, bro.
You're too slow.
Okay, but guys, can we just take this as a quick little watch out the modes you're in? One of these very different from one of these. Are we tracking?
Yes.
One of these is 57 of those. If I
See what it looks like in degree.
have my mode in radian and I'm plugging this in, it's going to be drastically, like something drastically different, a location drastically different than the one in degree. But anyway, you could plug that in and get a decimal, and then how would I find the y value? I can find x with the cosine because that uses the adjacent and the hypotenuse. How could I find y? Yeah, sine has a y in it, right? Something special that we'll be using in special equations called polar equations later on this year, but anyway.
Does it matter if
And in vectors. Huh?
Does it matter if it has like an x or a y like over like?
Well, I mean, it matters because, 47 is pretty close to 45, so these are pretty close to congruent. They're a little bit off, but if I was at something like up here, like 72 degrees, isn't it going to make a big difference as to which one's which? And so cosine, well, the x is going to be little, the y is going to be big. I need to be careful that I'm lining up the correct one with the correct one because cosine is always referring to this one and sine is always referring to that one. So I'm using the x to be the horizontal, the y to be the vertical.
So you just poke that. So you just multiply the 7 over.
Yeah, I'm just doing a quick little algebraic solving. Jackson.
So for that equation to figure out what the exact radian is, do you plug in the 47 degrees where that 1 rad is?
Yes. Well, careful. If you want how many radians this is, you would need to flip it, right? Because I need to convert my units, so I need the degrees to go away. So I want the degrees on the bottom
Okay.
and a pi on the top. Then I'll know how many radians I have. This one I had radians, and I wanted to get rid of the radians. Now, careful, pi is a number. Radian is actually an understood unit. That's just how like the world works, how things are measured.
So how'd you get 57.3 from just that?
1
'cause of
times
pi.
180 over pi. If I had 2 radians, it'd be 2 times 180. If I had 3 radians, but I only was converting 1 radian. This was just a reminder of beware the mode. Sorry, this wasn't me solving, this was me saying what's your mode in, and be careful, these are very different. 1 radian and 1 degree is super different, so make sure your mode is in the right thing.
Wait, so that, like y equals 7 sine 47 degrees is totally different from the...
Yeah, this is me just saying what mode are you in.
That's right.
Yeah, what mode are you in? So I tried to, now I'm trying to be super separate. Beware the mode. And that's the reason why I need to beware the mode. So, you guys do theoretically have some different like problems that can come up with words and whatnot as far as, ooh, that's gross. I don't like that. That's not what we're at. We are at, the homework numbering is off. But that's my fault, not the TA's fault, because I didn't have that ready. Let's go to WebAssign. I have that open. WebAssign, it's 4.3 and 4.4, right?
Yep.
Maybe I should go Google Classroom instead. There we go. Ugh, everything else is not labeled correctly. I apologize. But we're doing 4.3 and 4.4, which is the geometry of the unit circle, and then just like, hey, all the trig functions, how can you guys do with SOHCAHTOA, CHOSHA, of special ones and of non-special ones. So we can pull up WebAssign. We can see if you guys have been getting stuck on any of these extra ones. But guys, check it. I know it's a word problem, but what is there ultimately behind the word problem? Isn't it just a triangle?
Yeah.
Right? And with that just triangle, they're giving me some information. They're not giving me other information. They're giving me some information. So it's a little bit different than what we just did, but question, first of all, is this unit circle, let's go exact, or is this calculator, let's go approximate? Cool. Approximate. But then how am I going to find this y given this information? Just in case this could be helpful in the 4.3 notes to have it written down. We could have a situation, but look behind it. What's the mathematical model that's there?
Is it y equals 115 sine of 78.
Maybe. Let me use your idea of sine, Andy. Is that okay? Can we start there real quick? Because sine is equal to what? Opposite over? Oh, struggle bus. We don't have either one. So no. But do that troubleshooting, because that'll lead you to the right answer, right? Do I want sine? Yes or no?
Wait, no.
What should we do instead?
So you got the hypotenuse.
Cosine? So cosine, we do have 115. Cosine of 78.3 is equal to adjacent over... I mean, I could do that, but then I have this, and what do I actually want?
So you need to do tangent.
So I could do this, and then I could do Pythagorean theorem, but then I just got some error when I solved for this decimal, and then I would get a little more error when I round it twice. So the way to have the most precise decimal, or maybe I should say the most accurate decimal,
Tangent.
would be just to use tangent. But do you guys see that this process is one that will get you to the right setup?
Yes.
You just want the trig that says, hey, you can go straight for what you want. I want y. Cool. Don't be afraid of having to rewrite it a couple times. Just go through and try it.
Yes.
And don't make it work. Don't force it because you're probably making it wrong. Just like if it flows naturally, tangent is opposite over adjacent perfectly. And the algebra would tell me to do what? Multiply the 150. I'm just going to box it, but you guys would plug it into your calculators and it would be correct with what WebAssign would want, as long as you're in what mode? Degree mode. We have a few people clocking it in right now. If you want to double check your calculator and make sure it's working okay, mode, degree mode. What are you guys all getting, hopefully?
5
Oh my god.
Negative
You could just look
28.12.
up how tall it
Are
is.
you in radio code?
That is how tall it
We
is.
looked up how tall it was and we didn't give the
5.31.
Does it
problem
work?
as
Yeah,
accurate, and it's
that's,
perfect.
that's how tall it is.
Yeah,
Wait, what's the decimal? Sorry.
Yeah, 555.
3, 1, 3, 9, 9. 5,
3139. So 314.
Yes.
Okay, so 314.
50.
Goggle around it now.
Goggle, otherwise known as Google. Yeah.
How do you do cosecant?
Oh, on your calculator?
Is it like the negative or
No.
side of the negative one?
No. It's like, it'll be.
divided by that.
Yeah, do you guys remember from last time? Didn't we go over this last time? I thought we did.
It'll be like this.
Okay.
And then,
I'll review real fast. Hold on, I have too many calculators opening. As I get my calculators opening and ready to go, do you guys mind going to 4.4? We can do lots of word problems, but I'm not sure that's necessarily like the bulk of your web assignment. Because I'm trying to get you guys the basics of trigonometric functions, knowing what they are, where they come from, and how to quickly find them and or use them when necessary. Where they come from, who they are, and how to find them quickly and efficiently. However, 1 second, I seem to be saying like memorize the unit circle or have a way of regurgitating these special sines and cosines and tangents. And the next second, I have you going to your calculator. Why? Because it depends on the angle. Is the angle a special one? So you should know what it is off the top. Well, we're getting there. Maybe not right this second, but we're getting there. Or is it one that is not a special angle and so we don't have any other options besides using technology? Well, I mean, I understand the use of it, and I appreciate it in lots of ways. But I also think it makes us lazy, and to some extent makes us ignorant if we only have knowledge based on what technology can give us. So life lesson. But just think about your argument that you're making for technology. What if you have kids one day and your little kindergartner says that there's a calculator? Do they not need to learn what a number is or what addition does? Do you not want them to learn their times tables? Or do you think that will paralyze them?
oh,
No, but I'm just saying, hold on. Your perspective to what you might have your kindergarten student do one day. Are you going to give them a calculator from day one and be like, oh, who cares? You don't need to know any of this? Like, so that they have no number sense whatsoever? Someone gives them 100 pennies one day and takes their like $50 bill and it's like, yay, I got money. And it's like, great. Now that's a stupid example, but you guys see what I say, right? Your perspective to a kindergartner is like university professors or professionals to you guys right now.
let's go.
No, think about it though. I know that you think that you know everything, but your perspective is just as limited to someone who is far beyond you. Far beyond me too. I'm not even pretending to be in that category. However, just think, if you're like, oh, kindergartners, no, you need to at least know how to like kind of play with numbers. Like they're a thing that shows up. That you're going to have some sort of number sense to be like a functioning, successful individual in society. And be able to function with the responsibilities that are going to be asked of you one day with bills and budgeting and stuff like that. If nothing else. Just think, someone far beyond you has the exact same perspective of the arguments you are making right now. Does that kind of make sense? Just something to think about, not something to necessarily judge you on, just think about. Food for thought. I'm going to open the door because it got kind of stuffy. I don't know about you guys.
Misty, who's the biggest math whiz in the school? For you? Uh-huh.
Oh,
To be honest, probably the comp sci teacher.
Which one?
The comp sci teacher.
Oh, does he teach only Java?
This one here.
I think he's only preparing them for the basic. I would imagine a textbook would have more. I don't know what all he's going to expose them to, though.
I just heard only Java from him so long ago.
But that's more of, I think, him building a foundation and preparing them for the AP. But I don't know what he knows or what he uses or what he does. And I'm not saying he is necessarily the whiz, but he has, I think, more experience than any other in more diverse applications. But anyway, coming back. So you guys are in 4.4 once again. I'm sorry, Ryan. There we are. We could have done more problems for sure, in 4.3, but I figured let's just get through the content and then see if anybody is currently stuck in WebAssigned and or get you guys into WebAssigned so that we can see where you are going to get stuck. But Noah, first, go ahead. Can I just at least make the connection that you can solve from, and then you can go. So as soon as you're like, oh, I see where this is going, then I'm good for you to go. Because this problem is so easy, and yet it's so tricky to begin with.
I think I got this.
Question, what are they talking about in this problem?
They want
The
us
point
to
on the
drop
terminal
point,
side.
There's a point
and then we make a triangle.
at the end. Ooh.
3, 4, 5.
Ooh. Somebody has some geometric sense of what's going on. They give us the point -3, 4. If nothing else, go ahead and draw it, right? How can a point have a sine or a cosine or a tangent? It can't. But they didn't just make it a basic, careful, those of you on phones, is it actually helping you in getting this content? But can a point have a sine or a cosine or a tangent? No.
But it's angled.
But can an angle drawn terminal side? Guys, we're assuming it's in standard position. What is the angle that we're talking about? Oh my goodness! It's obtuse!
What?
It's obtuse, not acute. If it's obtuse and not acute, the triangle you would draw is this one, right?
Big.
Oh no, it's not even a right triangle. So where's my sine? Where's my cosine? Where's my tangent? Law of cosines? Law of sines? No, that's chapter 6. Pause. I don't need,
Setting in.
for the angle, I don't need to make a triangle with the angle. All I need for this theta, which I know is kind of awkward, all I need for this theta is to spotlight what we call the reference triangle. The reference triangle, which is the same thing as the right triangle formed directly to the x-axis in the shortest way possible. To the x-axis, not the y, but the x-axis, the shortest way possible, however. Question, cool kids, what are the signs going to be? S, I, G, and S. The positives, the negatives in the second quadrant. Because if you just go on distance, that's going to be a positive and that's going to be a positive, but that's just like the first quadrant and this is not in the first quadrant. So you have to think about, wait, I'm moving what direction from the origin? Left. So my x needs to be negative. And my y needs to be positive. Isn't that what you already have?
Yes.
Oh, cool.
Oh my.
Section 4.2. Didn't we say that x is cosine and the y is sine?
Oh, and then it's 3/4.
But wait a minute. Wait a minute. But I thought sine and cosines were ratios of opposites over adjacents and adjacents over, opposites over hypotenuse. And adjacents over hypotenuse. What's the biggest side of a right triangle?
The hypotenuse.
So is this ever going to have the numerator be bigger than the denominator if that's the biggest side? What's the biggest the adjacent can be?
1 less.
Actually, 1. If it's on the axis.
Oh, because 1, 2, 3, right? So it'd be like 2 less.
What?
Alright. Or is that for just a 36?
If it's on the axis, remember the biggest that a cosine or sine can be is if there's a flat triangle and it's all used up on cosine, which is 1, or all used up on sine, which is 1. Which is awkward because it's not a triangle, it's like a squished triangle. But, I mean, the biggest that I can have cosine be is 1. The biggest this ratio can be is 1. Otherwise, everything's going to be less than 1. Why? Because this side is the biggest. So 1/2, root 2 over 2, root 3 over 2, 0.6, 0.9. This needs to be less than or equal to 1. So is that possible? The biggest cosine can be is 1, because hypotenuse is the biggest side of a triangle. So it can't be any bigger than 1.
3.
So what have you missed? Why am I putting a question mark? I thought it was just the x. I thought it was just the y. But what do we have behind the scenes that still needs to be true?
The hypotenuse.
So if they're telling me that you've gone over 3 and you've gone up 4, question, what does that mean? Is this a unit circle? How big is a unit circle? He has only a radius of... He only has a radius of 1. Over 1, up 1, back 1, down 1. There's my unit circle. Where's this triangle? Beyond.
It's huge.
So what do we have to do? We have to realize all these things we're learning for the unit circle with x's and y over x's are bound by the unit circle. If we have some generic triangle, is that guaranteed to be within? No. So what do we have to do? Not forget the Pythagorean theorem, which so many of us just forgot. The Pythagorean theorem says, oh, if you have a side of 3 and a side of 4, I know it's a negative, but still, the side length is 3, the side length is 4. Question, what's the hypotenuse? 5.
Oh yeah, 3, 4, 5.
It's a 3, 4, 5. Okay.
This was the easiest.
So, sine is, but you guys have gotten it? Cosine is, tangent is, you would have gotten the tangent right. Be careful. If you're strictly rote memorizing, you're like, oh, I'm going to always take the x. Wait, that's only for a unit circle. Because the x over the hypotenuse of 1 gives you cosine. So don't lose SOHCAHTOA. SOHCAHTOA is still always the overarching idea of, even in the unit circle, draw your triangle. The radius is 1, the hypotenuse is 1. That's why cosine is the x. And that's why sine is the y. So I put a quick little watch out for Pythagorean, or don't forget Pythagorean. Then I'll move. Question behind my back. Is that Joey Jackson? Somebody raised a hand. Andy? Nobody? Oh, but he was stretching. I bet that's what I saw. Watch out. Can I put it this way? Cosine theta, sine theta.
I suppressed it.
We could tell. It was cute. XY. This is only true where? Starts with the U and ends with the knit circle. Okay,
No way.
that's good. And that's only for my rote memorization people. Anybody else should have been thinking of SOHCAHTOA and just been like, oh cool, I have this, I have that, I'll find that, and then here we go. Okay, so that kind of problem, not too bad, right? No, whatever, you're good. I just wanted you to see there is a triangle with the 3 and the 4.
Yeah, I would have never gotten that.
Right? Right? But like, it's not hard, it's just, yeah. It would be something hard to come back and look at and be like, what? Okay, so what else is coming in 4.4? Ooh. Ooh.
Determined by the
Huh. Have we talked about this yet? How did we talk about it? What did I do? All students
Take classes.
all right.
Take calculus.
Fine, party poopers. Thank you, Ryan. All students
No, not all students take
take.
calculus.
I mean, it's obviously not true. Right? All of my
Then
students should.
Personal
You must become a super senior too.
You can take both. I have some kids in both.
You need to finish calculus.
You guys can bring stats back. I offered to teach it this year, but not enough kids signed up. All students take classes. Courses?
Are you gonna do it next year?
C's? Depends on how many people sign up. You have to get at least 15, I think.
What's more beneficial, calculus or math?
It depends. You can have a longer conversation. Long story short, in an introductory statistics course for like a data science major, which is one of like the largest growing, quickest growing, most projected, like highest projected career in the next, I don't know, 10 years, 15 years. Data science, your introductory stats course will use calculus. So it's one of those, is it good to get a foundation in stats? Yes. Is it good for many fields? Yes. Is it better for many fields? Yes. But is calculus the foundation of a lot of what you're learning and of a lot of other fields as well? It's just hard. It's hard to say. Statisticians, like university professor statisticians, I had one that I was taking a class with this summer, are like, yes, kids need a better statistical sense. COVID would not have been as bad. Not the effects, but the mental, emotional, relational chaos that ensued would not have been as bad if people's statistical sense was better. So there's this huge push that with everything being measured, and we did this no, you guys weren't, sorry, wrong class. We did this in pre-cal last year. You guys are in pre-cal this year. Because I was taking one of the courses. But long story short, in pushing towards calculus, the statistical sense and training has been lost. And so there's a huge push that like basic math education needs to change to give kids a better number sense, a better statistical sense, a better sense of probability and some of these other things that are messier, but still have mathematical principles behind them. But the problem is those very same statisticians that are like, yes, we need statisticians and we need people in society that think like statisticians, are like, but you can't take out calculus. So it's this weird, like, okay, sweet, so let's like totally change the math curriculum, and yet we can't lose what's been preparing them for calculus all along. So it's like this weird thing, I don't know. Come talk to me about your personal goals and ambitions and your desire for career and major and what you enjoy, and we can maybe talk about it. Students, all take, that's not in order, all students take calculus. What does that even mean, though? What trig functions are going to be positive? All of them. Why? Because the main three are positive, so what's going to be true about their reciprocals?
Gonna be positive.
They're going to be positive. How about the second quadrant? Sine is only one that's positive, and so wait a minute, who's his reciprocal? Cosecant, CSC, remember it's the co, because he doesn't have a co, so he needs a co in his reciprocal. That has a co, he doesn't have one. Secant, and that doesn't have a co, so he needs one. Cotangent. Anyway, sine
It makes sense.
and cosecant, sine and cosecant are going to be positive, nobody else. How about this last one? Or no, third one.
Tangent.
Tangent.
Is gonna be positive.
Why? Because those are negative, so he's positive. Who's his reciprocal then? Use the cotangent. Okay. Don't say that out loud. Okay, so outside this classroom, there's Grace here. How about the fourth one? Classes stands for?
Cosine.
All are positive. Sine is positive. Students, right? Tangent is positive and cosine. Boys in the back are distracted. What's new? Okay, cosine and what else? What else? See, they don't even
Roasted
know.
and posted.
That's the point. Cosine and who else is going to be positive?
Oh, no. Secant.
Secant. Remember, no co. Got it. Okay. But pause. Did you guys get down last time? I mean, it was there. It was in the notes. I said it out loud, but it doesn't mean you had tons of time. You guys caught that there are these really important relationships that I talk about all the time whenever I'm talking about trig that you need to have memorized? I'm sorry. It's just true. We got these down last time, right?
We have them.
We got a picture.
We got a picture. We have them.
Oh, yeah.
Yeah.
Oh, I forgot.
So with all that, like, where do we need to get them?
I forgot about that.
I know. We need to get these in our notes if we haven't yet already, because I'm going to refer to them. Now, the nice news is they're coming back in section 5.1, so I guess if worse comes to worse, we'll get them then. Again. But it might be helpful to get them now, just reminding you they're a thing. So these things like, hey, who's the reciprocal of sine? Oh, cosecant is the reciprocal of sine. And Jackson, you were asking me, like, does that mean I can use the sine -1 button in my calculator? Last time, just a quick review, what did you learn from the people around you? That doesn't work. So if I am in something like, oh, I don't know, let's do degree mode because that's what most of your brain's thinking, we should be able to know that the sine of 30 degrees is equal to what? Oh, no, just sine of 30. Sorry, basic unit circle. Sine of 30, it's the smallest little angle. It's the y that's not 0, but the y that's like the very first one off the ground.
1/6 radians.
That's true, but what would the sine be at pi over 6, which is at 30 degrees? What's the little opposite side? The smaller number. Not the bigger, not the biggest, not the middle. What's the smaller number? 1/2. So we should be getting out 0.5 if I'm in the right mode. Sweet! So what would cosecant be? Wouldn't cosecant flip it? Right? Cosecant would flip it, so what's the flip of 1/2? Oh! Or if you can,
One, no, two.
yeah, there you go. So flip 1/2 and you get 2, right? So what does this button do?
It makes it an error.
Value is not
Quick go to.
it does not help.
But wait a minute, it didn't let me. Oh, because I was supposed to put sine inverse of 30, right? Oh, my bad. Cosecant. Cosecant is no.
You can't put the negative one.
Yes, once again, syntax error.
Put the negative one.
That's the best song ever. Bob.
What's the button for? I just showed it.
It's
It's like
do
the opposite way.
It's the opposite way, it's the inverse way, it's the backwards way, it's the undoing way, it's the give me the 1/2 and I'll get you back to 30, whereas sine says give me the 30, I'll get you the 1/2. This is the inverse, just like, hold on, some of you were listening last week, weren't you?
Yes.
What other button has an inverse right above it besides trig? What other button has an inverse right above it?
LN. Yeah.
ln has his inverse, what else?
Log.
Log has his inverse, what else?
Sine, cosine.
All of the trig do, and the easiest one is probably squared, right?
Oh,
yes.
What's above are the inverse functions. So careful. If you want cosecant, if you want cotangent, if you want secant, what do you have to do?
Take the inverse.
Do it that way, or you can throw in your sine of 30 and you can use the reciprocal button. There's a reciprocal button? Yeah, there's a reciprocal button. I want sine of 30 and I want it flipped. We could do it that way. There's a reciprocal button, but these are not reciprocals. They're what again? Sine what and cosine what and tangent what? Inverse. All right, so I'm coming back. All students take calculus. I mean classes. Sorry. It's like a 13-year thing to break. Okay, so all students take classes. I think we already have it in our notes, so it's up to you as to whether or not you want to write it, right? Have I recently referred to something known as a reference triangle? Yes. That is what we did when we had an obtuse angle. So check it, write it. You're going to not like it if you don't pay attention to it in WebAssign. Here we go. Ready? I'm going to show in yellow what the reference triangles are. What the reference triangles are. For anything outside of the first quadrant. In the first quadrant, it's just itself. It's easy. But for any angle that takes us beyond, I was going to say outside of the first quadrant or beyond the first quadrant, you're like, you don't have a right triangle. Oh, yeah, you do. It's just over here. You don't have a, well, yeah, you do. It's just right there. And same thing here as well. But the dilemma is they are in different quadrants. They are landing in quadrant 2, or landing in quadrant 3, or landing in quadrant 4. So if I'm talking about their trig functions, I am going to use little baby first quadrant triangles, little baby acute triangles, that would measure up to a slice in the first quadrant. Sorry, I'm back on calzones. That would measure up to ratios in the first quadrant. That would measure up or be symmetric to the first quadrant. And that is how we are able to find sines and cosines of tangents of angles that are too big to even be in any sort of triangle. But especially even a little baby acute right triangle. So we have this little guy called, ready? Reference angle is going to be alpha. Here he is. Here he is. Here he is. You guys doing the alpha? Do you remember that in WebAssign there's a Greek button, and the Greek button will take you to the Greek alphabet? You can use the alpha if you're trying to type an A and it's not working. Found that homework problem, right?
I did it.
Not infinity. And beyond. Would it make sense if you were trying to find the reference angle from which we will do all of our opposites and adjacents and hypothenuse? We're going to have a negative, we're going to have a positive, a negative divided by a positive will get us, oh well. Anyway, we can talk about all the signs again. Just kind of reminding you, the distances are always positive. But if I'm having this triangle in a different quadrant, I do need to think about signs changing. But that's not the point of this page. The point of this page is how would you find the reference angle? The reference angle would equal when it's in the second quadrant, or would equal when it's in the third quadrant, or would equal when it's in the fourth quadrant. How could you find it? That's what we're trying to answer. Andrew.
Sorry, what's the symbol?
Alpha.
Alpha,
Yeah. Alpha. And I'm probably making it, I mean, I think alpha is actually a little bit more like an A. Like it's pretty straight up and down, something like that. I'm just going fast. Suppose like little fishes, but that's not alpha. Fishes. Ichthus? Anyway. Does it make sense that I'm going to say theta minus, no, wrong way. That would be a negative. 180 minus theta, or pi minus 1? No, pi minus theta? Why am I using 180 and why am I having that be the first number? Why am I using pi and having that be the first number to find what this little guy is? Where am I drawing my triangle to? The x-axis, and not the 0 or 2 pi or 360 x-axis, but what am I drawing it to?
The opposite.
The opposite, which is, what angle is that?
Pi or 180.
Pi or 180. So I'm saying, like, hey, it's a little bit shy of 180. How much shy? Well, do subtraction. Good old-fashioned math. Good old-fashioned math. It's a little shy of 180. Okay, cool. Subtract the 2 and you'll know how much, and that'll be my reference angle. But does it make sense in the next one, guys? I'm going to switch the orientation, and I'm going to make the angle be subtracting the 180. Or the angle be subtracting the pi. Why does the angle get to go first this time? What's true if it's landing in the third quadrant?
Only cosine.
All students take only tangents positive. But just for the angles, sorry, I reminded you that the signs are going to play a part when we go there, but just for the angles, any angle in the third quadrant, hasn't it passed 180? Isn't it bigger than 180? If it's past it, how do I know? Did you guys notice up here? Reference angle, acute angle between. You know what? There's something super important I need to talk about that describes the positioning. The reference angles are always only positives. Reference angles are always or only positive. Reference angles are always or only positive. So I just need the bigger angle to come first in my subtraction. The bigger angle in the second quadrant is 180. The bigger angle in the third quadrant is the angle. And then, wait a minute. What's the bigger angle in the fourth quadrant? Careful, we're not going to 270. We can't subtract. We got to get up to the x-axis.
It's 360.
It's 360, yeah. So I'm going to do 360 minus theta. Or 2 pi, if I'm doing it in radians. Some of you with a good geometry sense, like you, as long as you hear the reference angle is the little baby acute angle to the x-axis, like you can kind of make up these formulas on your own, but for those of you that need those formulas to plug into, like I got you, and there it is, okay?
Well, I just had deja vu.
Deja vu. All over again? That's a little redundant. Okay, the slide is there if you guys need to get any more detail. However, once again, this is like step 1 in solving for trig functions of, remember, section 4.4, any angle. So not just 90, but going past 90, into the second, into the third, into the fourth, which we've already technically done. But this is the book saying, okay, go past. Once you go past, and once you've figured out your reference angle, then you make a triangle with your reference angle. Wait a minute, haven't we been doing that all along?
Mm-hmm.
Get your angle wherever it's going to land, form your triangle with, okay, so then, I mean, you can just say make your reference triangle if you want to shorten it. What is your reference triangle? But I'm going to go ahead and, just like we did a couple slides before, watch out for the signs. Assign, ready, signs to the sides. I know length, and I know length is, how long is it? It's always a positive number. However, we're talking about direction as well, so we need to assign the positive or the negative to the side lengths as appropriate, as we just talked about with all students take classes. And then to solve for the appropriate trig functions, it's just like, okay, no big deal. So, toa, if you have a triangle, or cho, sha, cow, if you have a triangle. Or for these guys, just flip those guys over here. So in some ways, there's nothing new, but in some ways, Jackson and Andy, in some ways, there's nothing new, but in some ways, this reference angle notation and vocabulary is new, okay? So in some ways, there's nothing new. But in some ways, reference angle, reference triangle, it's a little bit new. But basically, this is just saying, you know what, the unit circle doesn't just work for the first quadrant, it works for all the quadrants. But I think I've already kind of been testing you on that, so it's just solidifying the idea. Not testing, but having you practice that. Let me freeze the screen real quick, because I would love to get into WebAssign soon, so I'm going to go ahead and pull that up. Okay. So, what do you guys think? What do you guys think? We have just heard this would be very helpful for WebAssign homework. So what do we think? Nice thing is, how many of them are degrees? Would you guys have noticed that this one does not have a degree mark? So it's understood to be radians?
So we might convert it to degrees.
Question! What quadrant is 300 in?
4.
Because it's 90, think 9. It's 180, think 9 times 2 is 18. It's 270, think 9 times 3 is 27. And then 360, but it's 60 shy. It's right there, right? 300? Oh, didn't I just say 60 shy?
Mm-hmm.
Guess what I'm going to use that 60 shy to be? A reference angle. We might call it like theta prime. I'm just going to call it alpha to make it a totally different letter. Plus, you guys know Greek. Some Greek letters. The reference angle is just 360 take away 60. No big deal.
Oh, wait, so we just take away the difference between each, like,
Get to the x-axis
yeah, okay.
in the shortest way possible and make the subtraction to get there. But be careful, in something like letter B, we are in radians.
Did we do
So
this
it's
last
not
year?
y-axis and x-axis, it's just the x-axis?
Where's 2.3? Ryan said we can convert to degrees. Could we take 2.3 and can we convert? Yes.
Yes.
We could multiply by, the conversion factor is 180 over pi or pi over 180. Where do I need the degrees?
I got it. I have
Hold on, don't tell me yet though. And we're going to get from Ryan in just a second what that is. I need the degrees. So it's 2.3 times 180 divided by pi. That will give me how many degrees this is, so I have an idea. But wait. We are trying to get a little stronger at being able to do radians. Aren't radians, instead of a circle, make some generic circle. Hold on. Ooh, that's a rough circle. Aren't they radiuses measured around a circle?
yes.
The other day, right?
Oh,
measurement
yes,
around,
yes.
measurement across.
I remember.
A radian says, take the radius and do what to it? Measure it around the circle. There's 1. Where would 2 be?
Right there.
There's 2. Where would 3 be? Right there. And remember, 3.1415926 would be right there. Pi. So where would 2-ish be?
Yeah.
I don't need to convert. I just need to know, oh, it's a radius, and I map it. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Anyway, Ryan, does that match up with you? You should have gotten something like 130-ish?
Yeah, 131.780.
Is that something past 90? Yes. What did I need to know? I needed to know what quadrant it is because where do I find my alpha? Jackson, ready? Get to the x-axis the shortest way possible, right? I don't need to do that in degrees and then to convert back. All I need to know is, hey, what's this angle in radians?
Pi.
I just need pi minus. And actually, you know what? I'm not even going to do any math because I want to keep it exact unless they tell me not to. I'm just going to say pi minus 2.3. And that is the reference angle.
Oh, so you just do.
You can change it to degrees. You can do 180 minus, then you can change it back. Or I don't know what that would be. Brian, you still have it, right? What is that 180 minus that answer?
Sorry, 1 second.
No, you're okay.
48.22.
Then you'd have to multiply it once again by get rid of the degrees. So 180 on bottom, pi on top. And then that'll lead you back. But I think I would just rather know where it is and just do pi minus and be done. Andy,
So what if you had an angle after pi?
here we go. Wait, no, 135 is less than, wait. Negative 135, doesn't it have me going over here? 90 and 45 more? Which is the same thing as 3/4 of a calzone. It's 345. So I'm past 180, right? Now this was a little bit of a dilemma because if I just give you a formula, if you guys don't understand what's going on, you might get a little confused as to why I'm about to make this 45 degrees. Because if you do 180 minus, it's going to get you like 215. That's gross. That's definitely not a reference angle. So Andy, a couple different things. Well, first of all, it's just 180 take away this, right? Because 180 would be the whole line, and I take away the 135. If you think about it like a positive angle, that's one way. Another way is you could think about this angle itself, which has not yet gone past. Technically, it would be pi, not minus. How would you think about this? It's not quite there. I think you would think about negative 135 plus pi, or plus 180. I think that's how you would think about this one. But in general, Andy, let me answer your question with one that's going the positive direction. If you're going the positive direction past pi or past 180, you just need the bigger angle first, so everything just switches. You do the angle, take away 180. Over here, it was a little bit shy, so I did 180 minus or pi minus. If it's a little bit past, it would be angle minus pi.
Wait, but what if you were doing it in radians?
Yeah, angle minus pi.
Or radian minus.
Because the theta is going to be bigger, so I need the bigger minus the smaller. So either theta minus 180 or theta minus pi.
that makes sense.
Yeah, does that make sense? And so what we're doing in each of these is we're trying to figure out what's that quickest way possible to the x-axis, but I need to keep it positive. Some of you are ignoring what I just wrote down, and it'll make it wrong for you in WebAssign for at least one, if not two, if not three tries. So how does this section end here? Wait a minute. Doesn't this kind of look like unit circle stuff? Why are they ending on the unit circle? We did the unit circle in section 4.2. Like, I don't understand. Why is it back to the unit circle?
Use what we learned.
What's the title?
Any angle.
Trig functions of any.
And any angle means I don't care if it's just the first quadrant. I can get to the second quadrant and have a right triangle. Get to the third quadrant and have a right triangle. Get to the fourth quadrant and have a right triangle. Do you remember in 4.2 I said there was some geometry, but we were just going to use the ordered pairs? We didn't really use the geometry because this angle isn't inside a right triangle, but his reference triangle works. This angle isn't inside a right triangle, but his reference triangle works or is one. This angle is not inside a right triangle, but his reference triangle is. We had to talk about some specific like geometry ideas in order to say we're allowed to look at right triangles for each of these angles in different quadrants. So check it. Some people teach the unit circle, aka the special trig values, by saying, do you know what type of angle this is? What would his reference angle be?
We break past.
The way that some people think about it is, how many 180s? If we were to convert,
A little over
1/3 of 180, guys, what's 1/3 of 180?
60.
If you have thirds of 180, you're talking about some sort of 60s. If you have fourths of 180, you're talking about 45s. And if you have sixths of 180, those are those weird radians that show up, right? Sixths of 180, you're talking about 30s. Why? Because if you reduce, that's 30, that's 45, and that's 60. That's a way to place it in the unit circle. And 4 pi over 3, can you guys tell me what quadrant that's going to be?
Third.
Because you have all 3 slices and one more, right? You have 3/3 and one more, 4/3. We know that's a 60-degree triangle, so we can just pretend we're dealing with geometry in the 3rd quadrant. And to be honest, I know the unit circle is limited, but we can go outside the unit circle if you love geometry, and we can do what you did at the beginning of class. Look, it's 60 degrees. If it's 60 degrees, we can say something like across from the 30 is the 1, across from the 60 is the root 3, across from the 90 is the 2. And then I would say, remember to put your signs. If you love geometry, all you need is to figure out where is this to get the signs, what angle is it to figure out the triangle, and then just go ham on it. Go Sokotoa, Choshikawa. What do you need? You need ka. What is ka?
Opposite.
No, ka.
Adjacent.
Adjacent. Wouldn't that be -1/2? If some of you guys like geometry and like triangles, can you, now I know the unit circle is small though, the unit circle is technically like half of this because it's only to 1. So your little ordered pair would be here, and your little ordered pair would say, cosine's -1/2, sine is -√3/2. Unit circle would get you to the -1/2, but so would geometry, as long as you know what triangle to draw. Geometry would get you to the exact same -1/2, like your unit circle would. Jackson, do you hear me showing another way? Your unit circle would get you to that answer, but so would figuring out the reference triangle and identifying your sides to say, ha, I can do cosine, I can do sine, I can do tangent, I can do any of the Sokotoa Choshikawas. Andy?
Oh, why is it 2 not negative?
You can think about it's a radius of a circle, and a radius is always positive. You can think about the Pythagorean theorem. When you add 2 squares, it's going to be a positive. Yeah, we call it the radial arm, that hypotenuse. It's just what's being spun, and we're not talking about direction with it. We're just talking about length. But good question. We only talk about direction with what's being directed, like left versus right or down versus up. Not out. Good question, though. So when they give us something like tangent of -210, I'm just going to a new slide so that you guys can kind of ponder and do whatever you need to do. Tangent of -210. Are you going to find a -210 in your unit circle labeled? This is kind of, Ryan, your coterminal thing. Are you going to find -210 labeled in your unit circle? No, you didn't put negative numbers in there, right? Did you put negative numbers? No. But could you think about where that would land?
150 degrees.
How'd you get there, Ryan?
You add 360.
Oh, so he's actually like reference angling. He's like, oh, hey, the closest thing to 210 is, oh, careful, if you add 360, you'll get 150, and then that lands you in the 2nd quadrant. Yeah, that works. Or you could go -180 and then go a -30. But like Ryan said, he figured out, well, 360, like that's kind of close. How close? 150. Oh, so it's 150 that direction? It works either way. -210 goes that way. +150 will would go that way. They do make 360 if you think about just the angle measures. But guys, what's his reference angle? If you want to do the triangle thing. Yeah, he's a 30 degree. If he's a 30 degree, isn't that at that 6 pi over here, that 5 pi over 6? Is there something there in the unit circle? The answer is yes. There is a over a lot and up a little. Back a lot would be a negative. Those x's are all negative in the second quadrant. Back a lot, up a little, that's that negative root 3 over 2 and 1/2. But you could also just think of geometry and say, wait, it's going to be a little bit outside the unit circle, but I could think about this triangle and say this is a 30, 60, 90. And I could label it with, there's a 1 there, there's a 2 there, there's a root 3 there. I could throw in the signs and say, haha, I'm going left, I'm going up. And then I could also steal out my tangent this way. Wait, what way? I haven't solved for my tangent at all. Let's take Ryan's question and then see what our tangent would be. Go ahead.
So what would be the difference between them just giving you like negative 210 degrees and tan of negative 210 degrees?
Negative 210, they're just talking about like a location, a trajectory, a direction to head. Tangent says, how are the opposites and adjacents related? So 210 is just like an angle location. Tangent of negative 210 is saying what's the ratio of that opposite over adjacent.
Okay, so it's trying to ask you to find that ratio.
And specifically just for you to know, tangent, opposite over adjacent, is the same thing as, section 1.1, midpoint and distance, is the same thing as, ready? Opposite and adjacent.
Rise over run.
Tangents are rises over runs. Wait, rises over runs, those are easy, whatever. If it's a line, you just do y2 minus y1 over x2 minus x1. But that's only for a line. For a curve, how do you do a tangent to a curve? I just introduced calculus to you. You're welcome. Tangents are the ways to find slopes to tangents, or to curves. Sorry. Tangents are the way to find slopes to curves. But anyway, coming back. Tangent, super important guy, Ryan, for the future, but for right now. Tangent of negative 210, the rise over the run, the slope of the curve. I haven't done that yet. So how would I do it? Ready? With the unit circle. Wouldn't we need y over x, guys?
Yes.
For the unit circle, I would take the y. I would take the x. You guys should have done this in section 4.2 of it. With geometry. And the reference triangle that we've made. All you would need is opposite over adjacent. Do they end up being the same thing? Yeah. They end up being the same thing. But it's up to your brain as to which one you thought was easier. One says, give me the triangle, I'm going to do Sokoto Achoshikau to it. The other one says, you know what, just give me the x's and y's, I'll know what to do. They both get you the tangent, but they get you the tangent different ways. I could do one last example of this guy. Like another one. But I'd rather show you guys my one last technique for doing quick, efficient trig ratios of special angles. And I want to use it right directly after this problem. Now, first of all, I don't love this problem because it gives you degrees and it's having you do degrees. I would much rather have it be something like tangent of negative 5 pi over 6. Because that's the other way of looking at it. It's almost negative a whole calzone, but you're 1/6 shy. But either way. Oh, negative 210. Sorry, I went too far. That'd be negative 7 pi over 6. You have a little more than that 1 calzone. Negative 6/6 and one more. But either way, however you look at it, for tangent, as soon as you figure out it's a 30, as soon as you figure out it's a 6th, I introduce you to one final way. That students in the past, oh look, I have a nice little diagram of it. Hold on, look at my nice little diagram. Here it is. call this my, well, technically not my. Technically a college professor's of a student that failed geometry, failed algebra 2, but wanted to be a financial advisor, and she was doing it and doing it very well, but she had to get through business calculus. So in college, she had to retake a lot of high school math, which meant that she had to see the unit circle a lot. This is what allowed her to ace anything and everything where trig came up, even though she failed it in high school. Why? Because at the top of every paper, at the top of every assignment, at the top of every test, she learned just to draw her cheater chart, and she learned how to use it. To where she didn't have to think about any geometry triangle, she didn't have to think about any sort of unit circle pairs. Her brain worked best with the cheater chart. And the cheater chart says, ready? So, ha, toa, the main three. That's the order. And it goes through, you do have to learn your angles, but it went through 1, 2, 3, 3, 2, 1, all over 2. P.S. There has to be square roots too, so that's not really a part of the song. That's just kind of something that you learn. 1, 2, 3, 3, 2, 1, all over 2. Square root of 3, over 3. 1 square root of 3. Boom, boom. That's the whole thing. What whole thing? Well, that's everything inside the first quadrant. Can you guys tell the numbers are counting up? So it's from 0 to 1. These are counting down, so it's from 1 to 0. And then tangent is sine over cosine, so 0 over 1 gives you 0. 1 over 0 gives you undefined. Hey, guess what? That's also tangents, vertical asymptotes. Those are important to learn. P.S. Some exchange students from Brazil came, and they were like, oh yeah, we learned this too. Shout out Luca Kohlberg. But he would sing the song in class, and it was like, yeah, that's what they learned in maybe even middle school. I'm not exactly sure. But at least beginning of high school. He came a little bit later. But 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, 1 square root of 3. What are these? These are all the special sines and cosines and tangents. Now you could make your own cheater chart for cosecants and secants and cotangents. Cotangent just flips. These guys literally like flippity flip flip, and that's a little bit harder. But how does that help? Well, what if I was to ask you something like, ready? Cosine of, didn't we have just a little bit ago? Cosine of 4 pi over 3?
Yeah.
If you know your cheater chart, and you know that the third is bigger than the sixth and bigger than the fourth, you learn that the third is in this column, all you can say is 1, 2, 3, 3, 2, 1. Hey, it's 1/2. Uh-oh, what quadrant? Well, all students take only tangents positive. He must be a negative. Woo! So then what if you were doing the one like we just did, which was tangent of negative 210. Let's just pretend it was in radians just for sake of illustration. Oh, a sixth. He's the first one. Square root of 3 over 3. But what sign would he have? Oh, wait. That's going to be in the second quadrant. All students, he's a negative. Anyway, we'll talk about it more next time. Because technically on RedWeb, I do have a quiz on Friday, but I think it's going to be more like a quiz-is on Friday. It's going to be more like a quiz-is on Friday, if we have time after homework questions. So it's not a high-pressure thing. It's just to come with web-assigned questions, we'll troubleshoot. Bye, guys. If you want your test, I have it, and I'll hand it out to you. If you don't want it, you'll get it Friday.
Our test script